So what I've done here in figure C is to decouple the linkages and the hydraulic cylinder from each other that we saw in the previous figures A and B. So each of these portions is made independent of the other with the intent of drawing free body diagrams of force vectors associated with various joints on these subsystems. In problems that involve hydraulic cylinders, what I would generally do, and this school of thought would vary across the board, what I would generally do is deal with the hydraulic cylinder itself. Now the hydraulic cylinder is BD. The intent of this hydraulic cylinder for this specific problem is to provide compressive load, or a compressive support rather, to linkage AC so that the linkage does not collapse and remains in static equilibrium. Hence, the hydraulic cylinder is in compression and the force vector is inward along the axis of the hydraulic cylinder, if you will, and has been denoted by FBD and FBD. Now what one must realize is that since the hydraulic cylinder is linked to the other two linkages at point B and point D, it is necessary to have equal and opposite forces at these 2 points. And those are equal to F sub BD again, but they are equal and opposite to what was assumed on the hydraulic cylinder. So that actually takes care of a bunch of forces. The hydraulic cylinder is in compression, and this results in equal and opposite forces at points B and D. And those are the most complicated forces perhaps on this problem, and that's relatively speaking. What we are left with is a hinge at E, which we know to have two reaction forces, and E sub x and an E sub y from previous chapters on static equilibrium that you may have encountered. A pin at C, which is very similar to a hinge and has two components, Cx and Cy, which as a result of being coupled at point C applies an equal and opposite Cx and Cy. So what you see over here in summary is a decoupling of the various elements and drawing the various force vectors for a free body diagram starting with the hydraulic cylinder in compression. So for a problem of a frame or a machine coupled with a bunch of linkages and perhaps something new or foreign such as the hydraulic cylinder, this would be your general approach. Figure out where the hydraulic cylinder is, try to understand whether it is in compression or tension, decouple all the various elements, perhaps start with the hydraulic cylinder, apply the force directions, and then on the equal and opposite forces at various linkages, and make sure that you take into account the support reactions such as pins and hinges and so on.